So, I wanted to do a video on underfloor heating. It's one of those subjects that really upsets me because 98% of the time it's not done properly. There's a lot of different factors in underfloor heating, and there's a lot of companies out there just throwing in like a generic pipe sensor. So when you've got let's say you've got two rooms, for example, you've got one that's a new build standard, and then you've got one room that's built out of single skin brickwork. Let's say it's an old Victorian property, but they've got the same floor area. Do you think that they are going to both need exactly the same amount of heat going into the floor? You're not going to need that, are you? You're going to want a lot more heat in the Victorian because the heat loss is much bigger. So why all of these companies are putting a generic 150mm pipe sensor into people's houses just blows my mind, you know. So yeah, it's really important that you actually get a proper heat loss calculation done of your house and work out what power, what watts per square meter, and then design your system in correlation to that. Now, heat pumps, they run off, and boiler systems, if you've got the right controls, they run off something called weather compensation. So as the temperature outside drops, the flow temperature will increase. Now, with the traditional type underfloor heating systems, I get phone calls all the time from customers saying, Adam, I'm too hot, and then I'm too cold, and then I'm too hot. So what happens is, on a traditional system, the boiler will turn on and you have a fixed flow temperature going into the floor, into the underfloor heating. Now, what happens is all of that temperature and power and thermal, it will warm the thermal mass right up. So what happens is when the thermostat is set at 20, it's going to carry on pushing the heat up, and as it hits 20 degrees, the thermostat's going to turn off. So obviously the boiler's going to turn off. But what happens is the thermal mass, the amount of heat in that floor is going to carry on coming out, and it's going to keep on rising. So you're going to get 21, 22, 23, maybe even 24 degrees before it starts cooling down. As it starts cooling down, you know, you're getting down to your 21, 20, and when it hits 20 degrees, the thermostat's going to turn back on again, but it's going to take a couple of hours to react. So what happens is you end up going like 19, 18 before it starts going up. So that's why you kind of get a weather, a sort of like a heat curve like this, up, down, constantly on underfloor heating. Whereas if you size the system correctly, the heat pump will turn on and it will increase and reduce the temperature with the outdoor temperature. So what happens is you end up coming up in temperature, and it will maintain that exact temperature in the house that you want, depending on the weather curve that you got. So if you fit all of your underfloor heat into 150mm pipe sensors, and you run it off weather compensation and a heat pump, what will happen is you will get uneven temperatures in the house, because obviously they're just going to be giving off the same amount of heat each circuit. So yeah, that's why it's really important. Now, the other thing that we do a lot is we actually fit the underfloor heating in a spiral configuration. Now, the most important thing here is that you have your flow return. So you get even pipe heat distribution throughout the floor. Whereas what you'll find is a lot of developers and builders will go backwards and forwards. So you end up with a lot of heat in that side of the floor, but this way it's going to be a lot cooler. So you get uneven temperatures within the floor. So this house here, we've obviously been asked to do the heat pump as well. So this is the first stage with the underfloor heating. So what we do is we obviously do a heat loss calculation, which is obviously the most important part of it. But then what we do is we save ourselves a lot of times. I actually send out my heat loss report to actually a company called Heat. And then what they will do is they will actually do all the sizing for the underfloor heating for us. So in this room here and here, we've got 150mm centers. This room here, we've got 100, and then in the hallway, we've got 200. And this is all being done in relation to what's required in heat. So the other thing that they will do as well for you is that we'll do all the mass flow rate calculations. So it will tell us exactly how much heat is required in, litres per minute in each circuit, so we can balance the system properly. Like, heat pumps really rely on decent balancing as well. What we don't want to do is put actuators on everywhere, and as in like a traditional system, because what happens is one room gets too hot, then it will turn the actuator off, and then another room will get too hot, it turn the actuator off, and what will happen with that is it will massively reduce the flow of the heat pump, and then what happens is the heat pump will start cycling, and then you can have problems with like defrost cycles and stuff like that if the heat pump hasn't got enough volume with inside the system. So it's really important to run heat pumps off open loop or open circuit. So yeah, so this is just an overview of the job really. I just thought I like to talk about underfloor heating because it's just one of those subjects that is massively overlooked, and I do personally think that the building regs should really start looking at it properly, because you wouldn't just put a generic, you know, radiator in a house, would you? So yeah, so this is a job. So as you can see on the plans there, so it's still a bit of the building site. So yeah, this is kind of obviously where we're at. So we've got this one here, which is all done. The kitchen, we've actually had to freestyle it a little bit because the plans are a bit different to what they were given. Obviously this is the hallway here. We haven't done that one yet. This is an afternoon's project, and then we've got this one with 100mm centers in there. So that's all done. And then what else we've got? We've got the underfloor heating manifold in here. We've got the 2 flow returns which go up there. They're into MLCP across because we couldn't get any copper in there. And then they disappear. They do need clipping still, these pipes actually, and they disappear up there. So yes, still got quite a bit to do. We've got quite a few radiators to change in this house as well, and the new heat pump, we were going to put a Grant R290, a nice black one in, and that's going to be sited there. So we've got sort of obviously the flow returns coming through. The other one's the pressure release, and then yeah, we bent it around there, look. And that's going through. Yeah, that pipe is, I know it's not straight, but that's the pressure relief because we need to have a bit of a fall on it. So yeah, if you've got any questions with regards to underfloor heating, please comment. I do genuinely think it's quite simple, but yeah, and obviously if you are inside the Berkshire and surrounding area and you're looking to have a professional actually look at your system and do it properly, then yeah, just give us a shout. Like you'll be able to find my details on Google. It's Eco Renewables. Yeah, so yeah, give us a shout, guys. Yeah, and if you like this video, obviously like and share it. Thank you.